So in our project, we focus on adhering to the responsible AI principles by ensuring the fairness, transparency, and accountability throughout the machine learning pipeline. And below here are the key steps and strategies that we employed. The first one is for the fairness. So bias neighborhood groups that we evaluate the prediction errors across different neighborhood groups categories like Brown X, Brooklyn Lane, Manhattans, and so on. So this allows us to measure if the model was the proportionality, the inaccurate for the certain groups, which could indicate a potential bias. And for the mean absolute error by group, we calculated the metrics like the mean absolute errors MAE and median errors, and also the standard deviation for the errors for each group. So, for example, we observed that the Manhattan had higher predictions errors compared to the other broad, and with promoted us to consider additional fairness strategies. And so for the feature engineering for fairness, we introduced the features like demand scores and the host density to better capture the regional and host level characteristics and aiming to reduce the system bias that could arise from the underrepresented areas. And so we for the XAI, we use the shape to provide the both global and local explanations for our model predictions. And the shapes summarize the plot, help us to understand which features like availability, 365, and so on had the most influence on the predicted prices. And for the validation and consistency, we compare the multiple models like linear regressions, lassos, SVR, random forest, and so on. And finally selected the light GBM due to its balance between the performance and the interpretability. So we validate our models using k-fold cross validations to ensure the consistency and reliability of the results. And for the ethical considering, we acknowledge that the real estate pricing could inherently reflect the social inadequacies, so we carefully evaluated our features to avoid the reinforcing these biases. So, for instance, we exclude the features like host name or host ID, which could introduce a privacy or demographic biases. And then we also pay attention to how availability and review the metrics that could help to reflect the access or the popularity that varies across the communities. And for the fairness visualization, we visualize the arrows disparities to increase the transparency. So the bar plots for MAE by neighborhood group explain showed where the model performs better to awards and helping the stakeholders to make the informed decision. And for the steps taken to address the fairness and biases, so we inputted the missing values and also scaled the numerical features to ensure the uniform treatment across the features. And for the feature selections, to avoid the potential bias or proxy demographic indicators. And for the model auditing, we evaluate the group-wise errors to detect and also mitigate the unfair treatment. And we also provided shape bias insights to explain the predictions to both technical and also non-technical stakeholders.
Our code enhances interpretability through the integration of shape, and this is done as follow globe interpretable with shape summary plot. We generated a shape summary plot using a sample of the validation data to show which features on average driven prediction. In explainable AI, with the shape section, you create a validation sample and convert it to the NumPy array. You then define a black box prediction function that's called the Patriot prediction model on our finalized model. Although the original code needs to a small fix, the overall approach allows Shape's kernel explainer to compute how each feature contributes to the model's output on average. The resulting shape summary plot provides a global view of feature importance, showing stakeholders which factors are driving prediction overall. This helps stakeholders understand the overall behavior of the model and which factors are most influential across the dataset. And for the local interpretability for individual prediction, we also figured a black box predict function for our package pipeline and use the shape kernel explainer to generate force plots for individual prediction. The same framework can be extended to explain individual prediction. This local explanation reveals the contribution of each features for the specific instance, which is essential when decision must be audited on a case-by-case basis. This local-level insight is crucial for explaining specific decision made by model, which support transparency and allow for targeted investigation if a particular prediction seems unjust or biased. This interpretability is critical for aesthetic decision-making because it provides a way to justify model output, detect the unexpected behavior, and build trust among stakeholders. In other words, when every prediction can be traced back to individual features and their contributions, you'll have a clear basis for verifying that the model's decisions are fair and reasonable. This is our project and explanations. Thank you for watching and listening.